Hi everyone, thank you all for joining. It's phenomenal to see such a huge crowd. Very frankly, when Smarak and I and Ankej, when we were planning this workshop, we planned for 5 to 10 people, very frankly. So it's phenomenal to see all of you here. So thank you all for joining and thank you for being partners for listening to the DJ together. So yeah, let's begin. Let's start. Smarak, are you there or are you having a tea break?
I'm here.
Awesome.
Is
You
my
want?
voice clear?
Give me a second. Give me a second. Harish, look, your voice is
Okay,
clear.
Harish is there.
We have Harish joining us.
Hello, people.
Yeah. So Smarak, you want to come on the?
Okay, wait. Just a minute. Zoom is slowing down my laptop.
Yeah. So first and foremost, I suppose all of you, or at least some of you, have got the email which was sent before the workshop yesterday. So if not, I'll quickly summarize it for you. So as mentioned, this workshop, by the name of it, it's Advanced Git and GitHub workshop, and we want to do justice to the name and the plan that we have for the workshop, and hence we will not be covering the basics of things like.
Am I visible? Okay. But I'm all green.
Okay, let us do it without your camera. So as we want to do the workshop by giving justice to what we have planned. Things like basics of Git, like installing Git, setting up the config, username and the email for Git, and all the basic configuration we will not be covering. So we expect you to know things like committing, pushing, forking, and cloning, all those basic stuffs. If any of you have any issues in those basics, if any of you have any issues in those basics, feel free to watch it. You will understand parts of it, hopefully a large part of it. You can refer to the starter kit of us to get the introductory guide ready. And this video will be there on YouTube, so for you to refer back to it later. And this workshop is, as the name, this is a workshop. So we don't have any slides. We do not have any materials to share with you. So it's going to be a hands-on session. So feel free.
I do have slides and it will be on GitHub.
Yeah. So
At least
so
for
I
Git.
think generic people. That's what we're trying to say here.
yeah. So and as the hierarchy of learning goes, you first learn Git and then you go to GitHub. And Smarak over here is one of the finest persons in the entire campus who knows Git. So over to you, Smarak.
Okay, all right. Do I have the permission to share my screen?
You should go ahead, try.
Yep. Is my screen visible?
Yeah.
Yeah, let's close the tabs from my research. All right, now github.com. Okay, Abel, will you merge the pull request that I'm gonna make now?
I think you should be able to do it, but go ahead, try. Else I'll merge, no issues.
Yeah, so okay, let's start right here. Okay, we won't be covering Git add and status and all of that like in detail, but just for the sake of it, I'm gonna do it right now. So for I'll just go through it very fast. So if you run Git status, you can see that what all files or directories are not being tracked by Git right now, or if there are any commits and which are not available in the upstream, like which is on the repo which you see in GitHub. Okay, so here I see that this directory, it shows /. That means this directory itself is not being tracked by GitHub because it's under untracked files. You can see that. Cool. Okay, now I'll do git add dot. You probably would want to use and like add files one by one when you want to be sure that you don't push something sensitive to the repository, which should only be on your local system. But here there's nothing like that, so I'm just gonna do git add dot, and that will push that will add everything that is not being tracked right now, or if there had been any changes to any files, all of that uh, to the git tracking. So git will start tracking those files. So let's do that, get that down. Yep. Now we see that we have got 6 files added to git. Now if we run git status, we see that these files have been added, and now we can go ahead and commit. So I'll commit added slides. So if you do git commit, it's gonna create a commit, and by specifying this -m flag and this message enclosed in double quotes, you can specify the message for that commit. Okay. That's done. So it shows that these files have been added, and we'll come to these later, mode 1000644 and this number that you see here. So we'll come to that later, and we see that this added slides message that we gave to it was added. Now if you run git log --1line, yeah, you see there was an initial commit before, and there's the commit that I currently made right now. Now I'm gonna push this to origin. Okay, we are going with main here. Sorry. Oh. Yeah. Okay. Now if I go to my fork, yeah, we see the added slides commit has been pushed and it's here now. So I'll go ahead and make a pull request. Do I need to do all of this, right?
मैं तो पीआर पेज में बात कर दूंगा, अरे प्रीव्यू में जाके वो कर दो, चेक मार दो, जल्दी हो जाएगा.
Anyway, it's broken now, तो छोड़ो.
Space in between.
Yeah, उससे fix करने में और time देगा, छोड़ो. I'm just creating the pull request. You can go and merge. And I do not have the permission to merge. So.
You want to merge it right now? What do you want me to do?
Yeah.
Give me a second, I'll merge it. Want to squash it? No? Simple? What do you want?
No. Nothing, just a normal.
Done.
Yeah, so it's done. Okay, so now if anyone wants to see the slides later, they can come into this github.com/workshop-adv-git, and yep, that's basically the repo. I'll also post this here. Yeah. All right. So So now let's get into the workshop. Okay. So, so many of you would have like, there are a lot of definitions of Git, which, and you can think of it in many different ways, but I usually like to think Git in this way. So you can think of Git like is that it's a key value store where the key is a 40-digit hexadecimal number. We'll get to that later. And the value that you are storing is the data that you have in your repository. So Git works this way that if you give it the content, it's gonna make an SHA1 hash. SHA1 is an algorithm that would take the content that you provide to it and generate a 40-digit hexadecimal number to identify that content, and that can later be used to point like find the content in the history of Git. All right. So the key is the hash of the data, and the value is the data that you wanted to store. So it works that way. And this thing to note is this is important. Like if the content that you are storing is the same, the SHA1 for that will always be the same. All right. So you'll understand the significance of it as we go forward. Now, set to this. So Git works by storing the data in forms of blobs and trees. So what are blobs? So blob is basically, this is an you can visualize a blob in this way. So it is basically an object which stores the identifier, which in case of the blob is blob. The size of the content, like this here is the content, including this /0 delimiter. So if you want to count this, you do 10. I missed a comma here, so if you include that, is 5 letters, that is 10 bytes, a comma and an exclamation mark, that's 12 bytes, the space is 13 bytes, and this /0 delimiter character, so that is 14 bytes. So in this case, effectively, it's going to store 14 here. And the last thing that it stores is the content. So here it is hello world. Now let's try to now how Git does that is it takes your content as an input and it runs this git hash object command. Okay, internally. You don't have to do that. Git will do that internally. So in this terminal, I'm gonna run this. I'm doing echo hello world. Then I'm using the pipe symbol to pipe this, whatever is the output of echo hello world, which will be hello world, of course, to the get hash object command. And I've specified this $stdin flag. So so that the get hash object command knows that it has to read the input from standard input. Now I run this. So it gives me back this 40-digit hexadecimal number. So this is basically Git took our content, added it to a blob, and generated a SHA1 hash for it. Now this SHA1 hash will be the identifier for the content that you have stored using Git at a particular time frame. All right. Now we know. I told that Git stores the data that you give to it in the form of blobs. So we can also check that by doing this. I do echo blob I give it the size 14, then the delimiter character to separate the content from the blob identifier and the size. So that's /0, then hello world. Close the quotations. Now I do get hash object and read from standard input. Sorry, I wasn't supposed to do that. If I pipe this through OpenSSL SHA1, which is basically how you would generate a SHA1 key using the SHA1 algorithm, SHA1 hash, you generate by this, using this. You can probably do that by other methods, but on my system I have OpenSSL, so I'm using that. So I run this. See, so it pipes out this output. So if you see that, then this hash and this hash are both same. Alright. So does anyone have any problem in this? You can ask by unmuting yourself. No one?
Good, Smart, you can proceed.
Yep, cool. All right. So effectively, if you do echo hello world and provide that to get hash object, it's gonna make this blob out of it, and then it's gonna generate the SHA1 for that, and that will be the identifier for the content that you gave to it. So that's how Git generates SHA1 keys under the hood. Clear the screen, full screen. Now, now if we do the same thing again, but this time I'm gonna pass in the -w flag, which is basically asking Git to store an object. Okay, this won't really work here. Let's make a folder. I cd into that folder, initialize Git. Now we do and pass in the -w flag here. Yeah, so if we see there's a .git folder here. Now let's check out the contents of .git. Okay, we see these branches, config, description, head, objects. So what we want to be concerned with is this objects directory. So now if we go in cd into .git, now ls objects. Okay, so what Git effectively did when we ran this hash object and read the input from standard input and wrote it to an actual object inside of the .git directory, what it effectively did is it took the first 2 digits from this hexadecimal number and created a directory with the same name. Now if you do ls object, okay, let's do a tree command directly, tree objects. So it created a directory 8a, which is the first 2 digits of this SHA1, and a file inside of this directory with the rest of it, with the rest of the SHA1. So that's how Git will store your content in the form of objects. Now this is, we can see 8a, b6 and b686 here because this is just a new Git repository I made right now. But ideally in a real world scenario, you'll have a lot of history and it won't be so easy to see all of this, because Git will start compressing the data to push it to the repository and keep track of all of the information that it has to. So it will start compressing that data, and it won't be so easy to see this. Yeah, so that's how Git stores our data inside the .git directory. So whatever information is required by Git to function, it's gonna store that inside this .git directory in the folder. in your repository folder, basically. Right. Now we come to trees. Okay, so what are trees? Trees basically contain pointers to other blobs and to other trees as well. It may be a little difficult to understand right now, but think of it this way. So, okay, we can use this image. Yeah, think of a repository where you have this folder called copies, which contains a hello-copy.txt, and you have a hello.txt file in the same level as this copies directory. Okay, so the Git is gonna store that info in this tree. Okay, here I have just mentioned a size placeholder for the tree. It can be, it will eventually be calculated by Git when it stores the data. So now if we think about what a tree is, a tree contains pointers, which are basically those SHA1 keys that it generates. And those SHA1 keys are pointers to other blobs and other trees. So in our case, this hello.txt file. So Git took the content from this hello.txt, created a blob, which you can visualize in this way, and it took the copies directory. So to store directories, it's gonna create a tree. So it creates a tree inside of this tree, which points to the copies directory. And inside of the copies directory, if you follow this arrow, is this the copies directory itself is a tree, and it has a blob inside of it, which is this hello copy.txt file. Okay, now let me talk about this. Now think that you have this statement, this line inside of hello.txt, and hello copy.txt also has this same line inside of it. So essentially the hello.txt file and the hello-copy.txt file are the same, barring their file names. They have the same content. So this is where Git's compression and the SHA1 keys that are generated come into play. So what Git will effectively do is, we have this hello.txt. It's not gonna care about the name of the file. You have this content hello world inside of it. So it has created a blob for that, and there will be a SHA1 for the same. Now remember that I had said, if the content is the same, the SHA1 will always be the same. And if you have that SHA1, you can get to that content. So instead of making two blobs for hello.txt and hello-copy.txt, which have the same content, it's just gonna use this single blob and use its SHA1 to point to that blob. So both hello.txt and hello-copy.txt point to this blob. So that's how Git is able to compress the data that you are giving to it. It also runs other compression algorithms to make the file content into binaries, which take less space, but that that is very complicated, and we don't really want to get into it. So this is how Git will store your data. And this is why if you want to create a new branch out of a branch, it is very lightning fast. Like you run git branch, the new branch name, and it just creates the branch right away. You don't have to wait for it. Earlier, before Git was there, you would have to wait for hours to create a new branch, because it essentially will be creating a copy of the an exact copy of the repository to refer to it as the new branch. But in this case, since you have the same content which can be referenced using the SHA-1, it simply creates a pointer for the new branch, and it points to that content, that it points to the same content that you have, and that's why it is very fast. Now the trees also store this metadata. So the tree has this type of the pointer, which can be blob for a blob or the tree for a tree, which you see here. The file name or the directory name basically copies the directory name and the hello.txt file name here, and the mode. So if take for example, you have written a script and pushed it to the Git repository. So Git is also gonna keep track of the mode of that file, which will let it know that this is an executable file, or this is a symbolic link. A symbolic link is basically an alias for a file at some other place which you want to have in your current directory. So if once you push that to Git and someone pulls that down, they will also have the same executable file or the symbolic link, and they don't have to think about changing the permissions for the file. They don't have to think about changing the permissions for the file. Okay, just a minute. There's puja going on at home. I'm mute for a... Yeah, sorry about that. Okay, so if the file is executable, it's gonna be executable. Now, if you remember, I showed the get add when I committed the files, it showed create mode 100644. So that mode 100644 was essentially this metadata mode that you have. So it makes other people's life easier. Now we go on to the next slide. Okay, so we have a concept of blobs and trees. Now we get into the concept of commits. So what are commits? Commits are basically pointers to the trees. Commits in Git are pointers to a tree. So we talked about how Git stores all of this information in a tree. So whenever you commit in a repository, Git will create a pointer which will point to the current tree that you have in the repository. So it will create a snapshot for the data in at that time, and the commit will be a pointer to that snapshot. The commit has all of this metadata with the author and the committer, which most of the time will be the same, because nowadays we are just the authors of the commit and we only are committing. Okay, so author and the committer will be the same in most of the cases. The date at which the commit was made, the message that you pass into the commit, and the parent commit. So think that there are 2-3 commits in a repository. So there will be the first commit. The second commit will be pointing to the first commit. So second commit's parent is the first commit, and then there's the third commit. Now third commit's parent is the second commit. It works in that way. And the SHA1 that you see for a commit is the hash of all this metadata and the content that you have created at that time. Okay, so the commit is basically a snapshot of the code at that point, at the point of time when the commit was made, and all of this metadata gets combined with it, and a SHA-1 key is generated. Okay, now let's get into seeing these commits. If we do ls objects, we have this 8a. Now you can run this git cat file dash t 8a 6b6. That was the hash. Okay, no, it wasn't. B686. Sorry. Get cat file -t 8ab68. Yeah. So what get cat file -t does is it returns the type of that a type of the object that this hash points to. So in our case, this was a blob, so it is a blob. It returns as a blob. Now, if we want to see the contents of that blob, we can run get cat file -p and 8ab68 b6. So it spits out the content that was stored in that object, which was hello world. Now, Git works on the concept of immutability. So once you have created a commit, it's never, you cannot change anything about it, because if the content changes, the SHA-1 will also change. The SHA-1 is dependent on the content that is inputted into it. So even if you copy all of this, all of the files, the contents of it, the parent commit, the message, the author and the committer, the date at which you create the commit, that timestamp will be different. So it's gonna be it's gonna generate a different SHA-1. So it won't be that commit you created earlier. It will essentially be a new commit. So once you have committed something, it's not gonna change. You cannot change anything about it. So that's sometimes people say that when rebasing is done, it's essentially rewriting history, but it's not. If a commit has been made, you cannot modify it. History cannot be rewritten. You can discard the old history and create something new, but you cannot change the history. Does anyone have any doubts till now? Nope. All right. Now, so I'm gonna talk about a few things that you can try in your workflow when you make commits. So let's make a new directory. I call it new dir, cd into it. I initialize git, make a file. You can see the hello.txt file is here. I add the file hello.txt. Now I do git. Now almost all of us started at some point with git commit. So in the beginning we just ran git commit. Something happened. An alien editor opened up, most probably Vim, which nobody knows how to exit. It's :WQ or :Q exclamation mark, by the way. And since then, we feared running git commit again. And we learned about git commit -m. We do, for example, this I am making the initial commit. Yeah, so we got into this habit, git commit -m initial commit. This does work, it works very well, and I'm not saying that you should not do this or you should ditch this completely, but when you are working on bigger projects or with a team and you could benefit by describing a commit, then you should go for describing the commit. Okay, so how to do that, I'll show you. So now git commit -m initial commit, this is gonna create a commit which says git commit -m, which has this message initial commit. It generated a SHA-1 for it and it stored this file hello.txt. Okay. Now let's create a new file. I'll do hello again. I'll call this file hello again.txt. So now we have a new file. We can check that by running get status. It shows that this hello again.txt is untracked. Now we need to git commit. Now instead of doing -m initial commit here, you can just run git commit. Okay, I forgot to add it, so I'll add it. Hello again.txt git commit. So it opened up an editor. I use Vim, so it opened up. I have set the editor to be Vim, so it opened up in Vim. Now what you can do here is you write the commit message the same way that you would have written in git commit -m. So I'll call this hello added hello again file. Now instead of leaving this at this point, I'll create a blank line, and now I can write a description for this commit. This is hello again. I can write a description for this commit. So I can describe my commit that added a file named hello again.txt which contains the following line, and that is hello again. This is just for demonstration. Usually you won't be doing this. You may have implemented a lot of code, and there's probably a lot of new features you have made which are going to be committed. So you can go ahead and describe those features here, because git commit will and later when someone sees the log for the commits, if they want to know about what each commit was about, like there's a feature one which was added to this commit. So if they search through the log, they can find that yes, this commit added feature one, and maybe something went wrong with that commit. So they can know that this commit is a faulty one, and they can think about rectifying it. Or maybe someone is browsing through the repository and they want to see how a change was made. So basically you should when you are working on a significant project where other team members are also working with you and you have lots of things going on, it's usually a good practice if you describe your commit in this way. Okay, now I can save this by doing :wq, which will write and quit Vim, my editor. So now it has created the commit. And now if we run git log --oneline, see, in case of one line, we just see these messages. Now if we do git log, just git log, here we can see that added hello again file and the description, the message and the description as well. So now when you have a large history, you can search through this log to find a commit which was about some particular thing. Okay, and how to use the editor that you want. So git keeps track of all of its configuration, and you can edit those configurations by using the git config command. So I'll do git config --global, which means git will use it for all the throughout your system. Then you can do code.editor. For me it is new Vim, so I specified nvim there. You want to use nano, you can specify nano here. You want to use Vim, you can specify Vim here. You want to use VS Code, you want to use Sublime Text, you put that here. Okay, so whatever you are comfortable with. So you don't have to fear about finding yourself in Vim or some other editor and not knowing how to use it or how to exit out from that. Okay, So mine is already set, so I won't do it, but you can always do this. And then you can, whenever you commit, it will open up the editor that you specified, and you can write your message and description there and save the file easily. So that's all about commit messages and description. Now we will think about stash. So does anyone know here what git stash does?
It saves your changes without committing.
Yeah, precise, something like that, but it won't actually save it to the working area. It will Git maintains an area for the stash, and it will save that into it. So we can, so now you think, why is it useful? Okay, let's think of this. We are in the main branch. Let's make a change. Hello again to hello again to.txt. Cool. Now we have this change that we don't want to commit yet. I just went ahead and committed it. Sorry. Git restore taste. Yeah, now it's not added now. So if we see, yeah. Now we don't want to commit this change yet, but we want to move to a separate branch. Now in in the beginning, I used to commit. I used to commit this, then go to a separate branch. So I probably don't want to commit. I don't want that that file isn't ready yet, and I don't want to commit it. So if I do git stash, it would say no local changes to save, because by default git stash is gonna stash the things that you have added, that are being tracked by Git already and have changes in them. If now in our case, hello again to.txt is untracked. Okay, so let's so to also include the untracked files, you use this flag git stash -u. So -u will tell Git to stash the untracked files as well. Okay, so now if we do git stash -u, it says that it saved the working directory, and the index state work in progress on branch main has this hash added hello again file. Okay, all right. Now you want to view the stash, you can do git stash list. So it shows the stash at 0 and the metadata attached to it. Okay, now our work is safe, which we didn't want to commit it. It's safe in the stash, and we can go ahead and check out a new branch. -b new _ branch. So we have checked out to new branch. Okay, that's cool. Now think about this situation that you updated you checked out to the main branch, you pulled the changes from the remote repository. Now you should have created a new branch and started working on it, but in a hurry you didn't. You started working on the main branch itself, but now you want it in a separate branch. So stash comes in handy in here as well. You can now, if we do a git stash list again, we see this, the identifier for this thing content is git stash at 0. You can do git stash apply stash at 0. Okay, now if we do git status on new branch, we see that the hello again to .txt file is here. Okay, so we didn't want to work on the main branch. So we moved our work that we had already done in the main branch, instead of deleting it or making a local copy and then creating a new branch and pasting that into this directory. We stashed it, changed our branch, and got that got those changes from that branch to this branch. Now, if you want to clear all the contents of the stash, you can do git stash clear. This will basically clear everything that's in the stash area and return back to you. Okay, now let's create another stash. I'll do the dash u again. Cool. I showed you git stash apply. So apply is useful when you want to apply the changes from the stash to the current working area, and but still keep that change in the stash as well. Maybe you want to do something with it later on some other branch, so you can keep that. If you don't want to do that, you can simply do git stash pop. So what git stash pop will do is, it will take the stash is stored in form of a stack data structure. So the latest stash is on the top of the stack. So what it will do is take the stash take the stashed contents on the top of the stack and apply it to your branch and delete it from the stash area, from that stack. So git stash pop. Now if we see that it applied those changes here. Now if we do git stash list, we have no stash remaining. Okay, it had also shown us this, that dropped ref slash stash at 0. So that's how it basically works. And now also we can think about the drop command. Okay, I'm gonna do git stash dash u again. You can also do this git stash list. So this is stash at 0. Suppose you have multiple stashes in the stash area and you want to delete some of it. So you can do git stash drop stash at 0. So it dropped the stash that you specified. If there had been multiple stash, suppose stash at 0, stash at 1, stash at 2, 3, so on, you can specify any of that and it will delete the one that you specify. So that's how stashing works. Does anyone have any doubts regarding stashing? Unmute and ask, it will be very good. No one? All right. Okay, now we are nearing the end, so let's get into merging and rebasing. So merge is the default way that you integrate changes from one branch to another. Okay, so you most of us that have worked with Git know that this is the way that you get the changes from a feature branch into the main branch. Okay, all right. So if we think of the scenarios, now this is the initial commit. This is the second commit which points to its parent, the initial commit. Then there's the third commit, and then there's this fourth commit. And from this fourth commit, we had checked out a feature branch. So we have a feature branch here. We made commits we made commits while 2 more commits while working on the feature branch, and this is the feature branch right now. Feature points to this commit here. So now what we mean by branches in Git is that a branch, this name of the branch, this feature or main, what we speak about, that essentially is a pointer to the latest commit on that branch. So if we are checked out to main branch, we have a commit at some point. Suppose at this point of time we were checked out to the main branch. So main would be here pointing to the latest commit, which will be the 4th commit here. And similarly, feature here points to the latest commit in the feature branch. So that's how branches work. And this is also a reason when you create a new branch, Git basically has the same content, the same tree, the same commits. It just adds a pointer with the new branch name pointing to the latest commit. Okay, now think that feature you checked out the feature branch and were working on it. In the meantime, two more commits have been made on the main branch. Now you have to merge the feature branch into the main branch. Okay, so that would happen in a way like that. Since we checked out from the 4th commit, and after that the 5th and the 6th commit have been made, there are 2 commits in the feature branch. So Git cannot directly take the changes and put that on top of it while doing a merge. So what Git will do is it will take the changes from these commits and it will take the changes from these 2 commits, and it will create a new commit combining these changes. Okay, now remember what a commit is. A commit is a pointer to a tree. Alright, so this is the snapshot of the feature branch, the latest commit on the feature branch, and this is the latest commit on the main branch before we merged it. Now when a merge commit is created, it's essentially gonna be a commit that has has 2 parents, which is the latest commit on the main branch and the latest commit on the feature branch. And that's how a merge commit works. So this is the default. If there are changes on the main branch, after we have checked out a feature branch, Git is gonna create this merge commit, and it's gonna integrate those changes into this merge commit. Now there's another thing that Git does, which is fast forward. You probably would have seen sometimes when pulling from the repository and merging changes that Git says it has fast forwarded and it shows you the changes that were made. So what happens in a fast forward is that you checked out a feature branch, but after that no more commits were made on the main branch. So what Git will do by default is it will take it can easily apply the changes from the feature branch on top of the main branch, and it will do this. It adds the commits from the feature branch to the main branch, and now both feature and main are pointing to the latest commit. Now maybe you don't want this. Suppose you want that a merge commit should be created, so that if you want later you can go back in the history and get into how each commit changed the code. So if you want to preserve that thing, you can use the $no ff flag. You can use the no fast forward flag. So it's essentially git checkout main and you do git merge feature $no ff. What that will do is similar to this, barring that these were not here. So it will create a merge commit even when it didn't have to, because you specified that yes, create a merge commit. Can't hear you. Can you speak again, Vedant, I guess? Okay. No FF. Okay, cool. Okay, see, maybe you want that maybe you want to preserve this history that this was made in the feature branch, there were commits on the main branch, and you want to know that these commits were made inside of the feature branch, which was checked out from this 4th commit. Maybe you in your workflow you want to preserve that history. If you if a fast forward is done, it will simply do this, and you have this linear history inside of main branch, and you have no notion of the feature branch that was there checked out and being worked on. Okay, so if you don't want that, and you want that a merge commit should be created and the history should be on the feature branch itself, then you can do that by so that you can go back go over it later at some point of time. You can do that by passing the noff flag. So is that cool? Okay, all right. Rebase. Yeah. Now, instead of merge, there's something called there's also another strategy called rebase. You can use rebase as instead of merging. So what rebase will do? Let's go over that. Rebase essentially means give the commit a new parent, that is a new base commit. So that's why it is called rebase. Okay. Now think of this. You had the main branch here up to the 4 commits. Then you checked out a feature branch. Commits were made. In the same time, main branch also had these 2 commits. Okay, now you want to integrate the changes, but you don't want the history to be ugly. Now think of the normal way of merging. What it will do is it will create a merge commit here and integrate the changes from both of the branches in that merge commit. Now that's when there was just one feature branch. Think that there's a big project, there are loads of feature branches, so if you want to go back in history, it's gonna be a hell. You will have to check the logs where you checked out, where feature 1 was checked out, where feature 2 was checked out. Then you have to go through those commits. So instead of doing that, you can do git rebase instead of merge. So what rebase will let you have is a linear commit history, something like this. This will be the final state. So now let's know how it gets to this final state. So you are at this point. The latest commit on main branch is this. The latest commit on the feature branch is this. You're at this state. You check out to main. You want you check out to feature. You want to rebase the commits in the feature branch onto the main branch. What it means is get the latest snapshot of the main branch, which is these 4 commits plus the 2 commits that were made after checking out. Then take these 2 commits and apply them on top of the latest commit on the main branch. So that's how rebase works. But remember, I had said that once you have committed something, it cannot be changed. Maybe you committed this, it may be the same content, but it cannot happen that you committed and rebased at the exact same timestamp. Okay, so it's gonna be a new SHA1, and it's not gonna be the commit that you had already. So what Git will do is it will rewind head to wherever you had checked out. So suppose head is here. Okay, you had checked out from this 4th commit. Head moves to here. These 2 commits that you have made are safely preserved in a temporary area. Okay. Now you have the head commit pointing here. Now you have 2 commits on the main branch waiting. So now Git knows that it has to apply these 2 commits. So it moves head here. Now you had these commits in the temporary area, Git will create a copy of these commits. So these will be entirely new commits with the same content, with different SHA1 hashes, and it will add them on top of the latest commit from the main branch. And in the end, you have something like this. Feature is pointing to this, the latest commit, main is pointing to the latest commit, and the head pointer is also on the latest commit. So that's how rebasing works. It can be a little tricky to understand. So if you have any doubt, please ask. I'll go over it again if you want. No one has any doubts. Understood in rebase. Understood rebase in one go. Great. Fast forward और rebase में difference समझनी है. Yeah, okay. I do not have a cat. Those are stray cats roaming around my home. Yeah, fast forward. So let's go back to the fast forward slide. Yeah, this essentially happened in the fast forward. Now, the thing to note is that fast forward happens when you checked out a feature branch and there are no later commits on the main branch. So what Git will do is it will just take these commits, apply them to the on top of the latest commit on the main branch. Now let's skip ahead to rebase. See here that you checked out the feature branch. After that, these two pink commits, these two pink commits were made. Now you want the end result to be a linear commit history. In this case, you do rebase. So what Git does is it takes these two commits on the main branch. That is cool. And earlier this was pointing to this fourth commit on the main branch. What Git will do is create a copy of these commits and change the base commit to this sixth commit. So in fast forward, there were no later commits, these two commits on the main branch. In rebase, you do have these. And if you did not have these, rebase will also take care of that. It will just tell you that it is already up to date, that there are no commits made on the latest branch. Is that cool? Yeah.
Smarak,
Yeah.
so I don't need to take care of the baseline when I'm merging. Is it so?
Can you explain a little more about the question?
Suppose there are multiple branches and people are working across multiple baselines.
Yeah. Yeah. So okay.
I
So
thought,
people are working on. There are multiple.
Take care of.
Yeah. Okay. Okay. So think of it this way. You and there's a repository. You and I both have forked it. Now you checked out somewhere. I checked out somewhere. Okay. Now you are working on it. In the meantime, I have completed my work. I rebased against the main branch from the repository. Now my commits, suppose I made two commits and two commits on the main, and now they are integrated into the main branch and pushed to the repository. Okay, so my commits are already there. Now you can rebase, and in this case, my commits are already there on the main branch and your commits get applied on top of them. Was that understandable?
Yeah. Thanks. Yeah. Thanks.
So that works. And by doing this, you get a really good linear commit history that you can traverse easily. Okay. So now this is now let's get into amending. Okay. Okay, so let's say I make a new file, some markdown file. I write something here. Save it. Yeah. Now I do git commit -m.
Just one additional question with the rebase workflow.
Yeah.
When, as earlier asked, when multiple people are working on the same project, different folks and everything. So anytime one person makes there are multiple open PRs, then one PR gets merged. Inevitably, there are a few conflicts caused in the remaining.
Yep.
So when those conflicts are resolved, and then you rebase those branches to resolve the conflicts, you end up requiring to force push the new commits. Is that an acceptable practice, or is that wrong?
Yeah, no. So okay. I'll go into the rebase slide again. Now see this. What I said here was the commit cannot be same. Okay, so Git will discard these, make a copy of those commits. Okay, so before you had these commits, suppose this was this had some SHA, this had some SHA, but now Git has created new commits and these SHAs don't match. Okay, so if you want, and if you try to push this, the remote repository, your fork has the older SHAs, and now you are trying to push this. So your remote repository had the head pointer pointing here, but now the head pointer is here, and the SHA ones are different. So the heads won't match, and you inevitably have to do a force push. Git complains that the head pointers are not matching.
All right. Okay.
Okay. Git. Okay, let's get back to this. I added the other.md file. Now I do git commit. Okay, I just realized I made a typo here. So what do you do? Maybe this was some important commit message where you wanted the spelling to be correct. Okay, so in that case, you can do git commit --amend. Okay, so what this will do is open your editor, which you have set in your configuration. Okay, I see there has to be an I here. I make it here. WQ. I quit it. So yeah, Git has. If we see the log now, it is initial commit. Okay, so you can fix those easily by using amend. Now think of another case. Okay, let's make another file. Touch main.md. Some content here. And let's make another file as well. Feature. Okay. Now I do, suppose I have two files. This is very complex. I forgot to, I just go ahead and add the main.md file, and I forgot about adding the feature.md file. I went ahead, committed it, main file added. The commit is done. But now I run git status. I see that I forgot to add the feature file. But don't worry, you don't have to create a new commit now. You can include that file in that commit itself, in the commit that you just made. Just go ahead, git add feature.md. It's added. Now do git commit --amend. Now see, changes to be committed as new file, feature.md, main.md. Both the files are included. And you can change the commit message as well. Feature file added. Now if you do git log, see, main file added, feature file added, and this commit contains both of the main.md and feature.md files. So in situations where you forgot about adding a new file, you can use append there. So that's the end of my slides. I'll also share this tip. Now I had told about told about the commit descriptions. Okay. Now let's do this. If you don't want to see the descriptions, you do git log /1line. It shows you a concise history. If you want the full history, you do git log. It shows you this with all the descriptions. Now think that some feature was made which I want to go back. I want to find the commit. There are hundreds of commits in this repository. I want to find the commit which had this hello again in it. Okay, so what I can do is git log, use the pipe symbol, grep commit. Okay, sorry, commit, not commit, hello again. So it searched through the log, found this one, added file named hello again. I probably did it the wrong way. You can also check the help in that case. Git log /grep. Yeah, /grep. Okay. Git log /grep equal to maybe hello again. Yeah, it just spits out that it found this hello again file here, and it now you have the SHA1. You know what commit it is. You can go about doing something to it, maybe something important, dropping that commit or something. So that's basically it. Now I guess Abel will be speaking about GitHub.
Hello everyone. Am I audible? Which I assume I am. How to revert a commit in Git.
How to revert a commit in Git. Okay, now I'll go over that right now. People think that reverts the commit, but it doesn't revert a commit. Okay, if you do git revert, okay, let's do a git log /1line. This time I'll do the no pager so that I have the output here. Okay, I have this hash 9C6D68. Now I want to do git revert. Okay, so what it's gonna do is it's gonna create a new commit which reverts the changes. The changes in the previous commit were that we added main.md and feature.md. Okay, so what it is gonna do is it's gonna create a new commit that does the opposite of what the previous commit, what the commit did, of which you specified the SHA. Okay, so if I go ahead and write this, and now it shows that it deleted feature.md and main.md. Now, but if you do git log, you see that that commit is still here, and you have created a new commit that reverts the changes from the commit SHA that you specified. There's also git reset, which you can do with this. So what this will do basically is the head pointer. Head, what is head? Head always points to the latest commit that you have in the branch. Now, and using the caret symbol, you can say that git reset --hard to the parent of the head commit. Okay, so the caret symbol specifies that go to the parent of the head commit. So if I do this, get reset --hard head caret, now we see that it says get head is now at main file added, feature file added. Now let's do git log. The latest commit which reverted main file added, feature file added is gone. That's how you delete the commit. If you wanted to if you wanted to delete, now suppose you want to delete 2 commits from here, the head is pointing here to this SHA, you can do git reset --hard head, then the tilde symbol, which will tell that go back in the history, and then you can specify a number. So here we want to go back 2 commits, you can do git reset --hard head tilde 2. Okay, so that will be git reset --hard head tilde 2. Okay, git log. It deleted 2 commits. Actually 3 commits. Actually 3 commits. Yeah.
Okay, so in this way we can change the history, na git history.
Yeah, no, you didn't change the history. You deleted the old history and you are gonna create the new history. It's not the same as changing the history that already existed.
Oh,
Going ahead and changing something in it.
okay. Yeah, got it.
You can't change commits, because if you change the content, the SHA-1 is gonna change. Now there are also other options that you can do. Git reset --soft. There's also git reset --mixed, but you can read the help files or the Atlassian Git docs for that. It is easy to understand, but sometimes it can be a little tricky, and we really don't want to get into that right now. Hard will basically, what it will do is it will completely get rid of the commits. In soft, it would change I guess it would take your working area back to where you want, but it won't get rid of the commits already. It will have those commits safe somewhere so that you can maybe use them in some other way. And what mixed does is some kind of a mix of soft and hard, which is a little tricky to understand. So that's it. Abel, I guess you'll be taking over now.
Hello all. Do you all want me to continue with the GitHub part, or you are too tired? Very frank question.
Please continue if you can.
Okay, awesome. That's all. Awesome. So I'll quickly start. For my part, there's going to be screen share. So I'll quickly start sharing my screen. So screen visible?
Yep.
Okay.
Yes.
So first topic that we'll cover is review and update someone else's PR. Okay. The parts that we'll cover is GitHub. So whatever is happening on GitHub, and probably you're collaborating with more than one person and you want to do some collaborative work. So it all starts with someone sent a PR and you want to review and change it. Okay. So, okay, this is my own PR. So let me find a PR. No PR. Seriously, bro. Tell me a project with a PR.
Dates, your PR is there.
Not my PR.
Create a PR, right?
I think that's the only way out now. Workshop advance.
कोई बनाओ PR.
No. What is the... Okay, got it. Got the repo. ठीक है. assume that it's my own PR, but still assume that someone else made it. Okay, the concept will be the same. Okay, do changes for a test. So when sending a PR, where is the checkbox? Sorry, there's supposed to be a checkbox over here. And sure. There usually a checkbox comes which I did not see, which allows the maintainers to edit the code. So okay, for those of you who do not know, PR works from branch to branch. Okay? So if you send a PR from your main branch to the upstream's main branch, if you do changes in your main branch before the changes are merged, the PR will get updated. So the concept is very simple. If the branch is updated, the PR is updated. So it is not like the PR and the branch are separate. So it's important that you realize that. Secondly, one of the another reasons why it is not the right practice to send a PR from your main branch is because, by from I mean this part, okay? is because by default maintainers have access to your branch when the PR is there. Okay. So right now, if anyone who is a maintainer of this repo can push to this branch. So had you sent a PR from your main branch, it means the maintainer can push directly to your main branch without you having to ever do any change, any validation or checking. So you won't even know. So that is one another reason why you should never send a PR from your main branch, because the maintenance can directly edit your main branch. Yeah. So what essentially is the command that you have to do is there's a command to directly check out the PR, but I rarely use that. The command that I usually use is that you go to the branch of this. So there are two things that you have to know over here: who is the owner and the repo, okay, and the branch, okay. So the command is very simple. Give me a second. Probably my Git clone won't work. Give me a second. I'm switching network because on the instant network it does not work.
Insti seriously doesn't allow Git also?
Or did I get disconnected? Hello. Hello.
Hello.
Yeah, you're here.
Audible. Awesome. So I do Git clone. So first and foremost,
one thing, Instagram doesn't allow GitHub also.
I'm running it using the SSH one, and SSH is not allowed.
Damn.
Yeah. So first and foremost, before doing anything, it's important that you check the branch you are on. Okay. Very important. Sorry. CD. Does anyone remember the project name? Seriously. सबसे पहले देखो जब भी डाउट हो कुछ भी हो always run git status and know where you are. ठीक है. So ideally in any project of yours, this should not be the case. ठीक है. That you should have your own local copy and that should be your origin. And the upstream should be the main repo. So that is something that you have to keep in mind, that your local copy on GitHub, your GitHub copy should be origin and not the main repo. So that is something that you have to keep in mind. So always fork the clone repo. So the command that is there, it's git checkout minus, sorry. So for the command to work, the first thing that you have to do is add the remote. Okay. So for the example sake of scenario, assume that I do git remote. I think it's delete. This is not the command. No, delete. No, it's a remove. Okay. So now I don't have any git remote. Okay, git. Cool. So first you have to know, you have to add this. So what to do, you go to code, you copy this URL, or you can copy the HTTPS one also, anything works. You copy this and you have to add the remote, git remote add. I'm naming it, assume you are from the reviewers, assume the reviewer's name is, let's say, DSC. So, and then you add this. The remote is added. You can check if you want to, it's added. If you want to see the URL full, you put git remote -v. It's done. The second step you want to know is on which branch it is there. I am seeing chats. Give me a second. Instead of Wi-Fi, kahan se aaya? I have a router at my room. This Zoom thingy. Yeah. The next you want to know is the branch name. So the branch name is here. Yeah, this is the branch name. Awesome. So what you have to do is this command git. First, git fetch whatever you added, DSC. You do git fetch DSC. If you don't do git, it won't work. It will say bar branch does not exist. Okay. So you saw this. So this is what you have to do: git checkout -t, and then you write this. Because this, why do I write this? Because this is a branch from where the PR has been made. Okay. So wherever the branch is there from where the PR is made, you write this. Okay. It could even be your reviewers repo. Like you assume, let's say Harish made a changes. I am checking out to Harish. So I'll add Harish's remote here, and it will be Harish / something over here, and I do git checkout that. And
what does -t do?
So what -t does is a two-step command. Okay. So it checks out to a new branch by this name. The new branch is on the local system. Okay. And at the same time, it sets to track the upstream branch of DSC by this name. So it's a two-step command which is listed over here. So which is the combination of git checkout and get set upstream. Okay, so it's a combination. It is usually the easy way out when you are reviewing someone else's PR. And once you do that, you are in their PR. You can do changes. So, and then once you have done the changes, since this is set to auto tracking, you can confidently do git push, because it will not push to your origin. It will not push to the main repo. It will push to this particular tracking PR itself. So you can confidently push. Okay, but for the sake of being double sure, always do a git status before pushing, because else sometimes it's possible that you do a mistake. So that is about reviewing someone else's PR and pushing it. And ideally in a scenario, although this is the way you can push and do changes to someone else's PR, ideally you should not directly push to someone else's PR. You should write comments or something, and just in case it's not working out well, you should push to their PR. But this is the way in which you can check on the local system, because checking on the local system, this is the way to do it. There is a GitHub CLI equivalent command, which I don't really use because I'm still getting used to GitHub CLI. But yeah, this is the way you can do using the git commands. There's an equivalent config delete delete something to hide. I don't know, weird question, but
Delete the configuration of a router, something about your router, not your router, delete.
I don't know.
I just wanted to make the life harder. You delete the configuration of the router and they have to configure it themselves.
Yeah, so that was about one thing that I had to cover. The other thing, let me see. Merge PR from CLI. So merging PR from CLI. Okay. So you don't have to. So the one thing over here is that you don't have to memorize commands. You will remember the commands by two ways. Either you memorize it or you learn it because you've done it multiple times. And there's no way to memorize it because there's always easy way to reference it. So you go over here, you click on this command and instructions, you can see the commands, as simple as that. So there is no need for you to memorize the commands. If you are doing multiple times these things, you will remember it at one go. So let me clarify one thing for you, because this command may look the same as this, but it is not always the same that you have to write. Take care. So git fetch origin. Take care. This origin. Take care. I'll explain nicely. Git fetch origin. Take care. The name over here has to be the same as the repo name over here. So if you named upstream as the main repo, it has to get fetch upstream, not origin. So if you directly copy paste this command, it won't work good. So keep that in mind. So the second command, git checkout -b designer night patch one origin slash, yeah. Again, this one, this is supposed to be the branch from where the PR has been made. Take care. So if this origin does not match, then you are supposed to change it. Give me a second. Give me a second. Yeah, cool, awesome. Git merge, cool. That's fine. Git checkout, git merge, git push. Yeah, once again, when this git push origin main is done, see, this is the part where you are merging the PR locally. So once this is done, it has merged the branch locally, and once you do git push, Git will match the SHAs of the PRs, SHAs of the commits, and it will know the PR has been merged. So if you run these commands on the CLI and you come back here, it will show that the PR has been merged. So we rarely use merging from CLI, but usually it comes handy when it has got multiple merge conflicts and you want to finish the entire thing in the CLI itself. So you clone it locally, you resolve the merge conflicts, and you merge from the command line itself instead of coming back to GitHub once again. So that is it about this part. Second, branch repo structure, welcome new contributors, single branch flow, multi branch flow. Yeah, cool, awesome. So I'll take the example of a repo. Let us go to here. And why does not hide? Because chat is there. So this is the repo that we are using for hack and idea. Take care. So if you do not, okay, first things first, the tools that are there, GitHub, whatever is there to assist you. Take care. So do not try to use everything that is there just because the feature is there. Good example of that would be workshop. Discussions. So Smarak and I thought, why not use discussions for keeping track of what to discuss, just because we wanted to use it for the sake of it. But then Smarak said Notion use karta, it's easy for us to manage. So the thing over here is, what I want to convey is that you don't have to use all the features that is there because it is there. Use it if you require it and the team requires it, because more and more tools is going to consume your time if you're not actually benefiting from it. So I'll go back to the example over here. So if you go to, let's say you are starting off with a repo and you want to do full-fledged awesome work. So you go to, let's say, Flutter/Flutter, and you see that they have got so many branches, multi-branch flow. So we will also do multi-branch flow. Acha lag raha hai, maza aata hai. So just because someone else does this or some large organization does it does not mean that you have to do it. So when starting off, start small. Okay. You can have a single branch flow which can do your entire project and then level up as and when required. So start with a single branch flow, then go to multi-branch flow. You can have multiple branches, like you can have a main branch and then a release branch, a beta branch, and then run it parallelly. Okay. Unless and until you need to use a feature or a tool, don't force the team on yourself to use it because it's going to consume more time. So if you're starting with a single branch flow, it's more than sufficient and it serves almost all purposes. Tools are there to assist you. Tools are there to assist you and not there to burden you. So if you think the tools are burdening you, it means you are using the wrong tools or you are using the excessive number of tools, very frankly. So choose wisely. So if I take the example of, let's say, the Hackinator website, which is Project Kiwi. So we have just one version of the project, which is the deploy project. We are not maintaining a deep beta copy or something. So for us, a single branch flow works. We had a 2-branch flow, but it was not making any sense to us because all the changes are same in both the branches. So hence we thought it's a single branch flow makes more sense to us, and we reduce the complexity. And I would say that is the right way to do it, because unless you require those facilities, don't use it. So go to a single branch flow. You can either have a system wherein for every commit a new version is deployed, or else you can use this releases. So what releases essentially are an extension of tags. So in the entire history of your commits, you can tag few commits. So if I go to settings or insights, Yeah, tags essentially are like marking few commits as special, or like you want to highlight them. So they essentially are tags. So you can have as many tags as you want for each of the commits. Okay. No, sorry, you can have as many tags as you want, but only one tag is allowed per commit, if I'm not mistaken. So the thing is that you can tag a commit. So tags will be like you tag this is version 1, or maybe beta release or something, and then you can create a release. Releases are pointing to a tag. Okay. A tag may or may not require a release, but a release definitely requires a tag. So that is how it is. But usually it is done combined. So you go to releases and you create a new release, and when you create a new release, it's also tagged also. So that is how it is usually done. When you're doing releases, especially in cases when it's APK based project or maybe an executable based project, you should ideally add the binary files here, because a release is pretty much like you are releasing a new version of the software. So if it's a downloadable file or a file just to be generated, so it's ideal that you add the file over here so that people can directly download it instead of having to deploy the project locally and seeing it. So that is the right way to do it for people to have reference later. So that's it about tags and releases. GitHub Actions basics, yeah, secrets using .env client server on the same repo. Cool. So GitHub Actions, some of you may have used this, some of you may not have used this. So GitHub Actions is a way in which you can automate your work from the repo to the server. So it's like a machine, it's like a online server to ease out the things for us. So one of the things that happens is you have some secret files, maybe a .env file or maybe a JSON which is a secret, which is not there in GitHub because it's Git ignored. So some file in Git ignore is there, which is not on GitHub, but it is required for the project to run, and you want to run it on GitHub Actions. So what do you do? So what essentially is done is, so you GitHub has this thing known as secrets. So in secrets you can store text, and these text values are accessible in GitHub Actions. So what you do is, there are two kinds of secrets that you will have, probably a text based or a file based. For the text based, you can directly do क्या बोलते हैं, I'll show you an example. Yeah, the best is to show an example. La, 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 la. Go to project dates. Yeah, assume that this GK project is a secret and you want to reference it. So all you need to do is this: you call this, and the value is accessible. But assume that you want it as a file. Assume the project wants it as a file. So what is essentially done is um, you output the secret into a file using this command echo. There might be other ways to do it on Linux, but this is one possible way to do it. So you pipe the output directly into the file. So that is how you do it before you actually run the file commands to build it. And this is the way in which you can have the project have the secret files, which is not there on GitHub because it's Git ignored, but it is required for running it. One of the things that you have to keep in mind is that some projects require you to use something known as base 64 encoding. So base 64 encoding. Okay. There are commands on Linux and Windows to run it. There's a small thing that you have to keep in mind while doing it. So if you're running it on Windows, it gets appended by the type of encoding it has been done. And if you run it on Linux, it comes as plain simple text file. So let me see if I can run and show it. Not command encode. Seriously? So let me open the file and show you. So while running this on Windows and Linux, one of the possible errors, which will take sufficient time if you don't know the error, because I'll quickly show you. Yes, this is how it looks encoded on the Windows systems. Let it open. So this begin and end certificate does not come on Linux systems. It comes if you're running the command on Windows systems. And I would recommend that you delete this and you delete this and you store only this part on the secret. Else it will not be able to decode on a Linux machine, because Linux machine expects you to have just this text file if you're using the default base64 decode commands. So keep that in mind. That is pretty much about the basics of using secrets. The final thing that I wanted to cover is using client and server on the same repo. So almost all GitHub projects for web-based projects will have a client and a server, a backend and a front end. So having the client and the server on the same repo is almost in all cases not recommended. You can have it, but the ideal way is either you do two repos separated, or you do two repo, one as submodule. Submodules were a part. Submodules, in short, can be considered as a repo within a repo. Okay. That is one way to do it, but in almost all cases, having two repos works for all the projects. The reason why client and server in the same repo is not recommended is because assume that you are in present state and you found out that 10 commits behind the present state, the backend repo started causing errors, but you want to use the latest front end. So then it becomes very difficult for you because it's same repo. So you want to go 10 commits behind just for the backend part of things. The similar could be there for the front end part as well. So if you want to traverse in history separately, then have separate repos. Else it is going to be difficult for you. So hence that is the reason why we would recommend to not use one repo for client and server. We have used client server same repo for one of the projects, but it is not the ideal way because we have learned it the hard way. So that is about the basics of it. Then few things I would like to say. Have a repo which has a basic structure, like things like the README file and stuffs. It makes the process of someone trying to contribute to your repo really useful and easy to understand. So I'll show this template repo that we have. So things like license, README, contributing file. Contributing file is essentially important for people to know how to contribute. One of the things that is there, as Marek mentioned, a project will usually follow either the merge flow or the rebase flow, never the both, because there is a thing here. So all these things and what flow is to be followed and everything is written usually the contributing.md file. And if you are a maintainer, we would recommend you to have a proper contributing.md file. Same goes for the README files. README file is like the home page. You can write things. This is a contributors bot that we use. If you all want, you can use it. It shows a list of all contributors in the README file itself. And that is pretty much about the basics of how we structure the projects and how Git and GitHub will essentially be useful to us. GitHub has got multiple features like actions, projects, wiki, discussion. And once again, these tools are there to help you out. And you don't need to use all the tools because the name sounds fancy. Use the tools only which is going to help you and the team. So that is about the basics what we had to cover. There were a few more topics which we wanted to cover, but due to lack of time, we did not. Which we can cover in a later session. One of them is submodule, and the other is interactive reviews, cherry picking, squashing, and everything. So that we'll cover in a later session soon. If you have any queries, concerns, feel free to ask, speak up.